Okay, we're now going to take a look at AS2 Physics 2 Jun2008 question 5. And again we're back to the explanation for diffraction. So what is diffraction? Diffraction is the spreading of a wave as it passes through a gap or around an obstacle. Okay, so diffraction is the spreading of a wave, or is the spreading of waves, and that's is the spreading of waves through a gap or around an obstacle. Now in this paper, this is the first time that we have 2 marks available for this. The 2 separate marks here are diffraction's the spreading of waves, and then it's through a gap or around an obstacle. So we're looking for those 2 key points. Then we have sketch the wavefronts of plane waves of equal wavelength approaching the 2 different width slits. So we're looking now here for how does the wave pass through a very wide opening, how does the wave pass through a narrow gap. So essentially then we need to find out, well, what is, okay, so we have 1.4, making it a little bit awkward first, so 1.4 to there's the next one, and then another 1.4 to there's the next one, another one 1.4. And when you're doing this question, I would tend to draw in at least 3, possibly 4 as it's going through here. Oops, 1.4 to there and 1.4 to there. Okay, so these waves now, I'm just going to draw those. That's the first wave that reaches that, and then these waves more or less straight through at this point here. And then we're going to observe some edge diffraction now, so get a little bit of edge diffraction as that goes, and then these waves tend to get just a little bit longer as we're going from there to show that diffraction effect. The important thing is that the wavelength here stays the same as the wavelength before. Alright, narrow the opening and we get substantial diffraction. So again, we're just going to follow that on through from there, and it's 1.4 to there, another 1.4 to there, another 1.4, and we're doing this because we want the wavelength to be the same all the way, because in diffraction the wavelength doesn't change. And now what's happening is these waves are actually acting as a point source from there, and so we're getting, and this is quite a difficult diagram to draw, but we're trying to keep the same wavelength all the way around, and this is where using a pencil would help. But so it shows up here, I'm not using a pencil. Okay. But again, large slit, only edge diffraction, wide slit, narrow slit, then it acts as if it's a point source. Okay. Describe very briefly an experiment then which could be used to demonstrate diffraction with light. And that would be very simply, we would have, well, you could have a laser shining onto a single slit right here, an adjustable slit, and then a screen. So we need to, that's the laser, this is an adjustable slit, and then this is a screen. Okay, so that's the apparatus. So we're going to just shine laser light through the single slit, and observe the pattern on the screen. And then adjust the size of the slit, so the width of the slit, and observe how that changes the pattern. So observe the change to the pattern. Right, there's two marks there, and I think that what you're looking for is adjust the width of the slit plus then the diagram of the arrangement, and that should get you your full marks.